it has been some time since the last AMC or competition math solution. So today I'm gonna be recording the 2019 AMC 8. And for any years that are later than that, please check the channel Intersegation for his solutions. So let's get it started. Number 1. Ike and Mike go into a sandwich shop with a total of $30 to spend. Sandwiches cost $4.5 each and soft drinks cost $1 each. Ike and Mike plan to buy as many sandwiches as they can and use any remaining money to buy soft drinks. Counting both sandwiches and soft drinks, how many items would they buy? So first, we're gonna get at most as much as we can for $4.5. So we're gonna do 30. So basically, we're gonna do the floor value of 30 over 0.5, which we notice is 46. So basically, this means that we're gonna get 6 sandwiches and we have $3 left. And then we see that we have $1 each. So therefore, we're gonna get 3 over 3, 3 over 1, which is equal to 3. So 3 more sandwiches, and the total would be 6 plus 3, which is 9. So our answer would just be D, 9. So number 2. 3 identical rectangles are put together to form rectangle ABCD, as shown in the figure below. Given that the length of the shorter side of each of the smaller rectangles is 5 feet, what is the area in square feet of rectangle ABCD? Okay, so we see that this is equal to 5, this is equal to 5, and this is equal to 5 from our definition. And we also know that these are 3 identical rectangles. So this basically means that this one is equal to 10. And because this one is equal to 10, and we know that this length is equal to this length, and it's also equal to this length, which all have the length 10. So our answer would just be the base, which is 10, or the base, which is 15, times the height, which is 10. So therefore, our area would just be 15 times 10, which is going to be 150. And that is our answer. So number 3. Which of the following is the correct order of the fractions 15 over 11, 19 over 15, and 17 over 13? So we notice that, is there any similarities between all of these fractions? Oh, yes. The numerator would always be 4 more than the denominator, right? Add 4, and add 4. So basically, we can just rewrite these as 1 plus 4 over something. And the something would just be clearly the denominator. 1 plus 4 over 11, 1 plus 4 over 15, and 1 plus 4 over 13. Now we can also see another pattern, which is that, we can just discard all of these ones, right? Since these will not contribute to the sequencing order, sorting order of these 3 fractions, and we just want to see the largest of these fractions. Now we can also notice that, clearly, a fraction is inversely proportional to its denominator, right? Since basically we're just dividing 4 into 11 pieces, 4 into 15 pieces, and 4 into 13 pieces. And clearly, we want to minimize the number of pieces to maximize the quantity of each several pieces. So therefore, we clearly would have this being the largest, which is 1, this being the second largest, which is 2, and this being the third largest, which is 3. And we'll just find the ordering that corresponds to what we have found, which is E. So number 4. Quadrilateral ABCD is a rhombus with perimeter 52 meters. The length of the diagonal AC is 24 meters. What is the area in square meters of rhombus ABCD? So we know that from the definition of rhombus, all 4 sides are equal. So therefore, each length would be 13. Now, we have one of the diagonal to be 24. And because these are equal, so we drop this length in their intersection point, then these 2 lengths are equal. And each one would have a length of 24 over 2, which is 12. And from here, if you remember your Pythagorean triples, then you can clearly see that this length is 5, but we're just gonna confirm square root of 13 squared minus 12 squared, which is square root of 25, which corresponds to 5. So, yeah. And now we have 4 such triangles with area of base times height, which is 12 times 5 over 2, which each area would have 30. So our answer is just simply 30 times 4, which is 120, giving us answer choice D. Now going on to number 5. A tortoise challenges a hare to race. The hare eagerly races and quickly runs ahead, leaving the slow-moving tortoise behind. Confident that he will win, the hare stops to take a nap. Meanwhile, the tortoise walks at a slowly, steady pace for the entire race. The hare awakes and runs to the finish line, only to find the tortoise already there. Which of the following graphs matches the description of the race, showing the distance D traveled by the 2 animals over time, D, from start to finish. So from here, we know that speed is equal to distance over time. So therefore, we know that in the earlier section, then the hare must have a greater velocity than the tortoise, which means that the earlier stage should be more steep for hare. And we also know that, because hare stops at a certain point, then its distance, or the change in its distance, must be 0. So therefore, we can already eliminate C and E, since there's no point at which the velocity does not change. So we only have A, B, and D. And we also know that tortoise must win the race, so therefore he must reach the end in the faster time, right? So therefore we know that A would not work. Now we want to find whether B or D will be the answer, and we want to look at how tortoise travels, right? Tortoise travels in a steady rate, which means that it's going to be a straight line. So therefore we cannot have D. So our answer choice would be B. Now number 6. There are 81 grid points in the square shown in the diagram below, including the points on the edges. Point P is in the center of the square. Given that point Q is randomly chosen among the other 80 points, what is the probability that the line PQ is a line of symmetry for the square? So we know that for a square, there are 4 lines of symmetry, right? 2 diagonal lines and 2 lines that crosses through the center. And these corresponds to this, and this. Now we basically just want to count how many lines are there. Well, how many points are there on it. So we see that there are 9 points for each of such diagonal. But are we done yet? Well, no, because we see that the midpoints are counted for 4 times in total, while we only want to count it once, right? So therefore we have to subtract this by 4, which would give us 32. So 32 points that we can choose from. Well, technically it should be subtracted by 3, which is 33. But notice that we want to choose another point that is other than the center, so therefore we have to subtract by 1, which is 32. So 32 points to choose from, a total of 81 minus 1 points, which is 2 or 5 after simplification, and this corresponds to our answer choice C. Now number 7. Shauna takes 5 tests, each with a maximum of 100 points. Her scores on the first 3 tests are 76, 94, and 87. In order to average 81 for all 5 tests, what is the lowest score she could earn on one of the other 2 tests? So first, let's find the sum of these 3. So 76 plus 94 87. We have 7 with 1 advanced to the next one, and 25. And now we notice that, so we want to average 81 for all 5 tests, then basically means that the total is going to be 81 times 5, which is 405. Right. So basically what does that mean is that this two tests that he's remaining gonna take is gonna have a sum of 405 minus the score of the first three test scores, which is 405 minus 257, and that is 148. And now we want to have two scores adding up to 148, and we want to find the minimum score that he could have on one of the tests. And notice that basically we want to find the minimum score for one of the tests. We want to maximize the other score, right? Which is, well, a value of 100, since the maximum is 100. And so we want to have 100 plus a blank, right? Which the blank is pretty easy to find, 48. Just some basic arithmetic, and that would just give us answer choice A. And this can be kind of certain because you already find a possible construction of the minimum value in the minimum of all the choices, so you probably would know that this one's gonna be correct. Now, number 8. Gilda has a bag of marbles. He gives 20% of them to her friend Pedro. Then Gilda gives 10% of what is left to another friend. And finally, Gilda gives 25% of what's now left in the bag to her brother Jimmy. What percentage of her original bag of marbles does Gilda have left for herself? So now let's take a look at here. So if we give 20% to someone else, then we're gonna have 80%, right? So basically 1 minus 1/5. That's gonna be left, and this is pretty much the same. 1 minus 1/10, and here 1 minus 1/4. So basically, so we have 1 in the original since we have the entire thing. Then we gave 20%, so we have 80% left. Then we give 10% to someone else, so we have 90% of that left. And then we have 75% left since we gave 25% to someone else. So we just want to compute this out, and this gives 4/5 times 9/10 times 3/4. That is equal to 108 over 200, and evaluate that out, that's going to be 0.54, which is just 54%. So number 9, Alex and Felicia each have cats as pets. So Alex buys cat food in cylindrical cans that are 6 centimeters in diameter and 12 centimeters high. Felicia buys cat food in cylindrical cans that are 12 centimeters in diameter and 6 centimeters high. What is the ratio of the volumes of one of Alex's cans to the volume of one of Felicia's cans? Okay, so let's just label each can. So Alex has a can that has 6 centimeters in diameter, which means 3 centimeters in radius. So basically, a can that's relatively thinner. And we also have Felicia, which she has a can that is 12 centimeters in diameter, which means 6 centimeters in radius and 6 centimeters in height. So, a larger can. So we're gonna find the ratio of their volumes. So basically, we're gonna have pi r squared h, which is the volume formula, and we want to find the Alex can over the Felicia's can. So pi r squared h over pi r squared h, which we don't care about pi since they're the same. And for Alex, we have radius to be 3 and height 12. And for Felicia, we have 6 as radius and 6 as height. And we simplify this fraction, we're gonna get 1/2. So this corresponds to our answer choice B, 1 to 2. Now number 10. The diagram shows the number of students at soccer practice each weekday during last week. After computing the mean and median values, coach discovers that there are actually 21 participants on Wednesday. Which of the following statement describes the change in the median and mean after the correction is made? So for original data set, there are 20, 26, 16, 22, and 16 again. Which let's just sort it to such that it's gonna be more convenient to compute the medians. 16, 16, 20, 22, 26. So now, there are actually 21 participants on Wednesday. So basically, one of the 16 is gonna be replaced to be 21. So let's just calculate the mean first. So mean for our old data set is gonna be 16 plus 16 plus 20 plus 22 plus 26 over 5. Now let's find the new mean. Well, we don't have to calculate this out because for the new mean, you notice that you can rewrite this as 16 plus 5, right? Since that's what's equal to 21. What you can see is basically just the old mean, just the old data set, plus an extra 5 over 5, which is 1. So we know that the mean should increase by 1, which means that these would not work. Now let's look at the median. So the new median, we're gonna have 16, 20, 21, 22, and 26. So our median is 21 now instead of 20. So basically our median also increases by 1, which is choice B. Now go on to number 11. The 8th grade class at Lincoln Middle School has 93 students. Each student takes a math class or a foreign languages class or both. There are 70 8th graders taking a math class and there are 54 8th graders taking a foreign language class. How many 8th graders are taking only math class and not a foreign language class? So this one is a pretty standard pi problem, which is inclusion-exclusion principle. So we have 70 that takes both a math and a foreign language. Well, no, 70 student that takes math, and 54 students takes a foreign language students. And by pi, then we know that there are going to be 70 plus 54 minus 93 students that overlap by taking both math and foreign language, so 31. And this seems to be appearing in one of our answer choice, but are we done yet? Well, no. So we want to take how many students are there who take only math class and not a foreign language class. So we want to have the number of people in this region, which is going to be the total number of students who take math class, subtract by the number of students who also take a foreign language class, which is 70 minus 31, giving us the answer 39. So number 22. So number 12. The faces of a cube are painted in 6 different colors: red, white, green, brown, aqua, and purple. 3 views of the cube are shown below. What is the color of the face opposite to the aqua face? Okay. So this problem, this kind of problem is kind of hard to describe. You just want to kind of find patterns from here, right? So first you see that, or you have to know where aqua is gonna be, right? So let's just draw some kind of line here. So if B is here and G is here, now we also know that B and R are adjacent, and there are only 2 faces that are adjacent to both B and R, and we know that W is gonna be this one that's gonna be here. Now we take a look at this one. So BG, and we know that there's gonna be two faces that are adjacent to B and G, and R already occupies one of them, so therefore I believe that P should be the opposite face of R. Oh, actually, excuse me. It's gonna be R and G. So R, G, B already occupies one of them. So therefore, so this basically means that the bottom face must be the one that adjacent to R and G, which is P. So now we only have one space left, and which is Aqua. So A is gonna be here. So the opposite face will just be simply red. Now number 13. A palindrome is a number that has the same value when read from left to right or from right to left. For example, 12321 is a palindrome. Let n be the least 3-digit integer which is not a palindrome, but which is the sum of 3 distinct 2-digit palindromes. What is the sum of the digits of n? So okay, 2-digit palindromes, right? Reads from same from the front to the backward. So this basically means that we're gonna have 10a plus b, and a must be equal to b, right? Since we might have a number in the form AA. So therefore, this number must be a multiple of 11. So basically we have 11 times a plus b plus c, since we have 3 distinct 2-digit palindromes, and a is not equal to b and is not equal to c. So what's the minimum such value? Well, clearly it's going to be 110. So basically the least 3-digit multiple of 11. So our answer choice is simply just the sum of digits, which is 1 plus 1, giving us 2a. So number 14. So Isabella has 6 coupons that can be redeemed for free ice cream cones at PD's Sweet Treats. In order to make the coupon last, she decides that she will redeem one every 10 days until she has used them all. She knows that PD's is closed on Sundays, but as she circled the 6 days on her calendar, she realized that no circle date falls on a Sunday. On what day of the week does she redeem her first coupon? So okay. So she'll redeem every 10 days. Alright. So this one we might need to do some kind of modular arithmetic. So okay, so we're gonna have 60 days, right? And so basically we have every 10 days, so 6 possible days, so we need a total of 60 days. Now let's just probably try each choice. Okay, so for Monday, then 10 days after is gonna be, so Monday will just simply be 1 mod 7, right? And 10 days after we just increment by 10, and that becomes 4 mod 7. So basically just want none of them to be 0 mod 7, but we already reached 0 mod 7 after 2 iterations, so we know that we don't want this, so A cannot be the case. So basically the generalized idea would just be we don't want an A, So we want a such that all of these 10 plus a mod 7, 20 plus a mod 7, 30 plus a mod 7, 40 plus a mod 7, 50 plus a mod 7. So all of these cannot be 0 mod 7. Now 10 mod 7 is just 3 mod 7. So this is equivalent to 3 plus a. Tw 20 plus a is just equivalent to 6 plus a, since we're just basically converting all of these 10, 20, 30, 40, and 50 into a modulo 7. So 30 is 2 plus a, 40 is 5 plus a, and 50 is gonna be 1 plus a. Okay, so now we also have an a here. So a is definitely not a multiple of 7, since we do not want to start on Sunday. So we want to find this value a. So 1 does not work, 2 does not work, 3 does not work, 4, 3 I believe works, and 4 does not work, 5 also does not work. So therefore our answer is just simply C, Wednesday. So number 15. So on a beach, 50 people are wearing sunglasses and 35 people are wearing caps. Some people are wearing both sunglasses and caps. If one of the people wearing a cap is selected at random, the probability that this person is also wearing sunglasses is 2 or 50. If instead someone wearing sunglasses is selected at random, what is the probability that this person is also wearing a cap? Okay. Let's take a look at this problem. So you have 50 people that are wearing sunglasses and 35 people are wearing caps. And some people are wearing both. So if one of the people wearing a cap, which is out of 35, is selected at random, then the probability that this person is also wearing sunglasses is 2 or 5th. So therefore we have 14 people that wears both sunglasses and cap. Now, okay. So we choose some people who are in the 50 people that are wearing glasses. What is the probability that this person is also wearing a cap? So basically just divide this number that represents the intersection of these. So 14 and then divide by the sample size, which is 50 that we're choosing from. That just gives us 7/25, which is our answer choice B. Pretty simple problem. Now let's go on to number 16. Chang drives 50 miles at an average speed of 30 miles per hour. How many additional miles do you have to drive at 55 miles per hour to average 50 miles per hour for the entire trip? So, okay. So basically we just want to find the number of miles that he drives total and then divide by the time, I believe. Yeah, so driving 50 miles at a 30 miles per hour basically means we take 1/2 hour. So we just set like an unknown variable called t. Then we have 55t, right? Since we're gonna drive 55t additional miles plus 15, then the entire thing divided by 1/2 plus t, I believe, and that is equal to 50. So the 15 plus 55t is equal to 25 plus 50t. So from here, we're gonna get 5t is 10, so t is equal to 2. And then we want to find the number of additional miles, so it's gonna be this quantity, which is 55 times 2, and giving us 110, which is just simply our answer choice D. So number 17. What is the value of this long product? Which you can see is gonna take forever to calculate. So you probably don't want to just multiply everything out. And a pretty good idea would just be try to find some kind of patterns. Now let's take a look. These parentheses are kind of misleading because you can't really simplify these fractions, right? This is 3 over 4, this is 8 over 9, and this is 15 over 16. So, not really useful. So for this problem, it kind of requires some kind of thinking outside of the box. So what if we just ignore these parentheses and instead we consider these kind of parentheses, right? These, and then there's gonna be a 4/5 here. Then we consider these. Now things becomes much easier to deal with. Now things becomes much easier to deal with, well, because these cancels out, right? And these also cancels out. So these are just a bunch of ones multiplied together, which would just give the same value. So we don't even care about anything that's in the middle, so not anything. So it basically just boils this down to be 1/2 times 100 over 99. Which is 50 over 99, so giving us answer choice B. So number 18. The faces of each of two fair dice are numbered 1, 2, 3, 5, 7, 8. When the two dice are tossed, what is the probability that their sum will be an even number? So this one we need some kind of parity analysis. So what kind of numbers is gonna sum up to an even number, right? So you can either have both odd plus odd, or even plus even. And these are only two cases. And you can just try to experiment with some numbers and you're gonna get that these are the only cases. So now, how many even numbers are there? Well, we have, the even numbers are 2 and 8. And the odd numbers are everything else, which is 1, 3, 5, and 7. So basically, we have a total of 4 times 2 possibilities, and then divide by how many, or divide by well, actually we're gonna get so we're gonna get a total of 6 squared, and we have we either choose both from here, and notice that we can even repeat, since you roll 2 dice, you can get the same outcome. It's a possibility. So we're gonna have 4 squared, then plus 2 squared. Just evaluating this out, we're gonna get 36 over 20, which is 5 over 9 after simplification. So our answer is just C, 5 over 9. Now let's go to number 19. So in a tournament, there are 6 teams that played each other twice. A team earns 3 points for a win, 1 point for a draw, and 0 point for a loss. After all the games have been played, it turns out that top 3 teams earn the same number of total points. What is the greatest possible number of total points for each of the top 3 teams? So okay, a team earns 3 points for a win, and 1 point for a draw, and 0 point for a loss. And each 6 team plays each other twice, so we're gonna get a total of 6 times 5, which is 30 total number of matches. So this basically means that each team is gonna play, well, so each team is gonna play 10 matches. And notice that for each of the game, then you can only contribute to the total score by +3, which basically means someone win and the other person lost, or you can have 1 point for a draw, so 1 point for each, right? So, So essentially, we just probably do some kind of experiment here. So we know that the maximum score that someone can earn is gonna be 60, which means that he must win all of the game, and that is clearly not possible because we have three teams that are scored the same, so we cannot have someone who win all of the games. And we also cannot have someone who. So we also cannot have one who have 5 wins and 1 draw, which would give us, I believe, so we probably can only have 7 wins. Well, because we have like a total of 6 teams, so we need to have 7. So we can only have 7 wins since we have like 10 matches for each one, right? So now the question just becomes, well, is it possible for any for the top 3 teams to have a different number of numbers of winning matches? Let's say if someone here got a 6 and someone get a 7 and someone get a 6, which would have well, then this person can lose all the 3 matches, and both of these have 3 draws. So that's one of the possibilities. And what about if all of them win 7 matches? Then probably if we want to maximize their score, then we want them to have some draws. So this wins 7s, and they have 3 people to play with. So he must have some kind of draw between, well, he must have some kind of draw between these two. So each one would have 2 draws against all of the others. So 23 would just be the only possible construction. And this gives us our maximum of 23 people. So number 20. How many different real numbers x satisfies the equation? Well, x squared minus 5 squared is equal to 16. So now, from here we can see that, well, x squared minus 5 is equal to 4, or x squared minus 5 is equal to negative 4. And then we notice that, well, this gives us x squared is equal to 9, and x squared is equal to 1. And from here, we need to find how many different real numbers x satisfies this. So for each of these, we can have plus or minus 3, and this is plus or minus 1. So our answer will just simply be D, 4. So number 21. What is the area of a triangle formed by the lines y equals 5, y equals to 1 plus x, and y is equal to 1 minus x? So let's just graph all the 3 lines really quick. So y is equal to 5. We just label the axes to be somewhere here. This is 5. So I think I probably need to expand this coordinate axis really quick. And also probably lower this time since we don't really have that big of space. So let's just say 5 is somewhere here. So y is equal to 5, and we have y is equal to 1 plus x, which basically means a slope of 1 with a y-intercept of 1. So something like this, and y is equal to 1 minus x will just be exactly the opposite, which is this. Oopsies. So we need to find basically this triangle right in the middle, right? So you might use like some more advanced technique, which is like, let's say, shoelace formula, but it's just not necessary. So we see that what's the intersection of this? Well, y is equal to 5, so 5 is equal to 1 minus x, so x is equal to negative 4. So this point is basically negative 4 comma 5. And what about this point? Well, pretty much the same. It's going to be 4 comma 5. And you can just check by substituting 1 plus x is equal to 5. You easily get 4. Now their intersection will simply be 0, 1. So this base is 8, and this height over here is gonna be 5 minus 1, which is 4. So basically, this is our triangle, and our area will just be 8 times 4 over 2, which is just 16. And that will just give us our answer choice, E. Okay, now let's go on to number 22. A store increases the original price of the shirt by a certain percent and then decreases the new price by the same amount. Given that the resulting price was 84% of the original price, by what percent was the price increased and decreased? So let's just set x to be like the percentage of increase. Then we basically want to have 100 plus x percent, well, after the x percent increase. And you might say, well, how is that possible if you increase the same percent and decrease the same percent? Well, basically, you're gonna decrease x percent from this, which is the x percent of this new quantity, not the old quantity. So this value would change. So let x be the percent, then we're gonna have 1 plus x, right? Or 1 plus x over 100. That's gonna be the quantity that you have to multiply by 1. And now we have to multiply by, well, x percent decrease, which is 1 minus x over 100. And this quantity must be 84 over 100. So we have 1 minus x squared over 10,000 is equal to 84 over 100. Now we multiply both sides by 10,000. We're going to get 10,000 minus x squared is equal to 8,400. So x squared is equal to simply 1,600, which x is equal to, we only take the positive, so 40. So this basically means 40% increase after, and then after we have 40% decrease, and we get 84% of the original price. So E. So number 23. After Euclid High School's last basketball game, it was determined that 1/4 of the team's points were scored by Alexa, and 2/7 were scored by Brittany. Chelsea scored 15 points. None of the other 17 members scored more than 2 points. What was the total number of points scored by the other 7 team members? So okay, let's just boil down this problem a little bit. 1/4 of the team's points was scored by Alexa, and 2/7 were scored by Brittany. So let's just set x to be the total number, right? So x is gonna be equal to 1/4 x plus 2/7 x, and then so we have, well, 1/4 of the team points were scored by Alexa and 2/7 were scored by Brittany, and we also have Chelsea scored 15 points. Now, none of the other 7 team members scored more than 2 points. Well, let's just set this to be some kind of number. So we're gonna get, well, x is equal to, well, 1/4 plus 2/7. What is that? Well, that is equal to 15 over 28x plus 15 plus 8. And just set to be this quantity. So we have 13 over 28x is equal to 15 plus 8. So we multiply this both sides by 28 over 13. Then we're gonna get x is equal to 15 plus a times 28 over 13. So essentially, we just want to find, well, what's the closest value that are less than 14, that is less than or equal to 14. And 15 plus a is going to be a multiple of 13. Well, 15 is already larger than 13, so the next multiple will just be 2 times 13, which is 26. And a cannot be negative, obviously, so we know that 26 is the least. So a would just be 26 minus 15, which is equal to 11. So our answer choice will just be B, 11. So number 24, a geometric problem. In triangle ABC, point D divides side AC so that AD to DC is equal to 1 to 2. Let E be the midpoint of BD and let F be the point of intersection of line BC and line AE. given that the area of triangle ABC is 360 degrees, 360 a unit square, what is the area of triangle EBF, which is just this triangle over here. So we have a bunch of ratios here, so this probably motivates us to just find some ratios, right? Now I know there's gonna be some more advanced topics such as mass point, and you know that this problem is pretty easy with just using mass point, but I'm still gonna just do it in probably the way that's gonna be more easier understood. So let's begin. First, we can draw a line that is parallel to BC and also passes through D, and we know that this to this is gonna be 1 to 2. So essentially, if we have side to be some ratio, then the area ratio will be the square of that side, or the side length ratio. And we know that, well, because this angle is congruent to this angle by the parallel nature of two lines, and we also know that they also share a common angle, which is this. So we know that triangle, let's just call this G. Then we know that triangle ADG is similar to triangle ABC, or the other way around. Triangle ADG is similar to triangle ACB, just to be more precise. Then we know that the area of triangle ADG is going to be equal to 1/9 times the area of triangle ABC, which is 40. So this part is 40. And what other information can we extract from this? Well, we see this triangle right over here. And what's this triangle? Try to not overthink here, because you don't need any similar triangle. You just need to know the base. And well, the base is 2, corresponding, which is twice the base of ABD, and so this one is going to be 2/3 times the area of ABC, which is I believe 240. So this triangle or triangle ABD would have an area of 120. So now can we find, well, now can we try to find this triangle over here? Well, we also know the ratio of BE to ED, which is 1:1. So essentially, we know that the area of triangle ABE is indeed gonna be the same as triangle, the area of triangle AED, which is gonna be 1/2 times the total area of them, which is triangle ABD, which is 60. And now at the end, can we try to find the area of ABF? Yeah, that started to become a little bit confusing. Since we already know the ratio of BF to FC, so we can't really find the area of ABF just based on all of these ratios that we have. So okay, at the end we probably still have to use the idea of mass point, which is not that hard. So we just assign this point to be 2 and this point to be 1. Now we also find this point to be 3, and this is 1 to 1, so this one will be 3. So from here we can see that this is 1 to 3. So essentially BF is equal to 1/3 of FC. So this basically means that the triangle this triangle is has an area of 1/4 times the total area, which is equal to 90, and we subtract that by the area of triangle ABE. So 90 minus 60 is equal to 30. Aha, very nice. We still have to use mass point at the end, but we got the correct answer, so it's gonna be fine. So number 25. So Alice has 24 apples. In how many ways can she share them with Becky and Chris so that each of the 3 people has at least 2 apples? Okay. So this problem, we see that the answer choices are pretty large, so probably not a good idea to just list all of them out. So what is probably a more simpler or more convenient way? So notice that all the apples are indistinguishable, right? So if we can just find like 3 placeholders, then basically we can just insert one of the apple. Well, I'm just gonna use 1. So we can just insert one of the apples to each of the 3. Well, at least 2 apples, sorry. So 2 for each. Now how many apples we have left? Well, we have 24 minus 2 times 3, which is 18 apples left. So we have 18 apples left. And how many ways are there to share the 18 apples with Becky and Chris, such that they have an apple that can be 0 or can be any natural number. So this boils down basically to how many ways are there to find 3 numbers or positive integers, actually non-negative integers a, b, and c, such that their sum gives 18. And that just becomes a pretty standard stars and bars problem. So the formula would just be a plus b minus 1 over b minus 1 if we want to assign like b placeholders. So in here, b will just be 3. Sorry to not mess up with these variables and a, b, and c. So b is equal to 3 and a is equal to 18. So our answer will just be simply 18 plus 3 minus 1, choose 3 minus 1, which is 20, choose 2. That gives 20 times 19 over 2, which is equal to 190, and that just simply gives our answer choice C. Thank you for watching, hope you enjoyed this episode, and I will see you in the next video.